Welcome to Casting Academy. Today our topic is Introduction to Engineering Materials. Introduction to Engineering Materials. As you know, in the entire world depends on the materials. So that is called materialistic world. Without materials, there is no engineering. Then what are materials? They are substances of composed of matter. The matter is composed of unit substances known as chemical components. A chemical component is a pure substance that cannot be broken further by chemical means. Finally, the smallest part of the element which exhibits all its properties is called an atom. Therefore, atoms are the basic building blocks for any materials. This is very basic, as you already know the introduction. Then engineering materials. Materials are classified in different ways depend on the field of science. Physically, physicists classify the materials as solid liquid gases. So chemists organic and inorganic. So physics can classify the material into solid liquid gases as well as chemist also organic and inorganic. But for an engineer, material means structural material that is used to produce very various engineering products. So from our engineering point of view, structural material. Next, classification of engineering materials. Classification of engineering materials. So engineering materials are classified first metals, ferrous and non-ferrous, ceramics, traditional and advanced ceramics. In polymers, thermosetting plastic and thermoplastics. In composites, fiber reinforced, particulate laminated, or polymer matrix, metal matrix, ceramic matrix. As you know, this common classification about the engineering materials. Number one, metals, ceramics, polymers, and composites. Here, what is the idea behind this? So, for single purpose, we can use different kind of materials. That is the engineering materials. Drinking, but that is this metal, paper, and ceramics. So this is the various approaches of engineering materials in for same purpose. Metallic materials. What are metallic materials? Materials are composed of one or more metal elements: iron, copper, aluminum, nickel, titanium, lead, tin, and zinc. These are iron, copper, aluminum, nickel, titanium, lead, tin, and zinc are known as metallic materials. So most probably used materials are iron, copper, aluminum, nickel, titanium, lead, tin, zinc. If major element is iron, then it is called ferrous metals. As you know, the cast iron and steel both are classified based upon the ferrous content and also carbon content. Here we discuss iron is a major element, then it is called ferrous materials, other known as non-ferrous. So what are the distinguished features? Relatively good strength, malleable or ductile, and resistance to fracture, excellent conductors of electricity and heat, opaque to visible light, shiny appearances, high luster. So metallic materials are strength, ductile, tough, opaque to visible light. These are all the basic features about the metallic materials. As you see the bridge, so various kind of applications in metallic materials. Applications: electrical wiring, structures of buildings, bridges, or in automobiles, body, chassis, spring, engine block, etc. Airplanes, body, engine components, fuselage, landing gear, assembly, etc. In trains, rail, engine, components, body, wheels, etc. Machine tool, drill bit, hammer, screwdriver, saw blades, etc. So these are all the metallic materials applied in various applications. Ceramic materials, as you know, the interesting applications is very in ceramic material: electrical insulators, abrasives, thermal insulation and coatings, windows, television screens, optical fibers, corrosion resistant applications, electrical devices, capacitor, transducers, etc. Self lubricating, this is very important. And nowadays metal ceramic materials are used in self lubricating materials, also magnetic materials, audio, video, tapes, etc. So ceramics are complex compounds based both metallic and non-metallic. It's a composed of both metallic and non-metallic. Example: alumina, silicon carbide, silicon nitride, etc. So ceramics are wide variety of applications and features: low density than most materials, stronger than metals, brittle, toughness or brittle, or low resistance to fracture, low toughness or brittle, low ductility or malleability, high melting point, poor conductors of electricity and heat. So this is the idea behind the ceramic materials. So same applications are electrical, abrasives, thermal insulators, windows. So as you know, these are all the different applications, right? Next, our important one is polymers. So polymers are consist of long molecular chains, mainly contains long molecular chains containing many repeated units of monomers. Example: nylon, PVC, etc. Polyethylene, nylon, PVC. So polymers consist of long molecular chain containing many repeated units of monomers. Polyethylene, nylon, PVC are the main examples. Features: composed of primarily carbon and hydrogen, which means hydrocarbons, low melting temperature and strength, most poor conductors of electricity and heat. They are easily molded into required shapes, some transparent, some opaque. So polymers are some transparent and some opaque. So polymeric materials applications: adhesives and glues, containers, moldable products, computer casing, telephone handsets, disposable razors, clothing and upholstery materials, vinyls, polyester, nylon, water resistant coatings, latex, low friction materials, Teflon, gasket and oil rings, rubber. So PVC have wide variety of applications. Composites of material. Composite materials are mixtures of two or more different materials that are mechanically or metallurgically bonded together. So composite materials is a mixture of two or more different materials that are mechanically or metallurgically bonded together. Distinguished features. The properties depends on amount of distribution of each type of material. For example, carbon is below 2% under the category of comes into steel, and more than 2% automatically goes into cast iron. So composites materials are depends of presence of various elements present. Collective properties are more desirable. Very, very important in ceramics. Collective properties are more desirable than collective properties. Collective properties are more desirable than possible with any individual materials. So composite, why we go for composite materials? Collective properties of more desirable. For example, glass fiber reinforced polymer. Glass fiber reinforced polymer. High strength of glass fibers are combined with the easily formable polymer matrix to produce strong structural materials. So composite materials are mixes of two or different materials by mechanically or metallurgically. So it's mostly collective properties are more desirable. Next, composite material applications. So flights and bridges and structures, variety applications. So as you see the application, sports equipment, golf club shops, tennis rackets, bicycle frames, aerospace materials, thermal insulation, brake materials, experimental aircraft, entire body composed of composites. Stellar pumper uses composite materials. Tennis racket made from carbon-based engine casing using alumina matrix composites. Next, our interesting topic is history of metals. So basically, we are all interested in history because of the story, uh, like stories. Materials play an important role in the evolution of the human culture and civilization. So in our history, so humans are grow with materials. In Stone Age, around 600 BC, primitive man used tools, stone, flint, wood, and bone are the for his livelihood. Gold and silver are where gold and silver were the too soft. The use of copper in antiquity is more significant than gold. The use of copper is more significant than gold as the first tools implements and weapons were made from copper. From 400 to 600 BC, coppers came into common use. So this is the history of metal. You see the picture. First, crude branch. First material is crude branch, an alloy of copper and tin. Branch is a mixture of copper and tin, occur accidentally as people lit wood fires. In place where mixtures of tin and copper are existed, the hard burnt wood, which means copper, would have reduced the ores to mixture of copper and tin metal, which is branches. Around 200 BC, people discovered that adding tin to copper during the melting process produced branch. So branch is a mixture of copper and tin. Because of branch was better than copper, could be used for many different things. It was sturdy enough and affordable enough to make everyday tools. Over the next 1600 years, bronze suppressed and replaced copper as the important metal to society. That is called Bronze Age. This 3600-year-old bronze stand from Cyprus shows man carrying an ingot of copper or bronze. So now you see the iron pillar. So after the Bronze Age, Iron Age comes. The Iron Age began in Asia and Africa in 1100 BC. Wrought iron was the major element. From iron known to man, Egyptians developed the origin of forged draft, the making of wrought iron, and they were used wrought iron for making swords, spears, blocks, etc. They used pillows are out of goat skin a palm nozzle and or air inlet valve, bellows for producing the metals. And approximately 800 BC, Aryans invaded India and the Indians learned how to make iron. Interesting on pillar dating to 400 AD remains standing today in Delhi in India. Between 700 and 600 BC, the Chinese learned the art of making iron. They were known to have made cast iron in the 14th century before Christ. Steel was produced in China and Japan about 600 to 800 AD. So, just you see the history of metals. The invention of blast furnace, large production of iron and steel, Bessemer converter improvement in iron production, open hearth furnace, discovery of nickel, discovery of manganese, tungsten, introduction to high speed steels, introduction of sporadic graphite iron. So this is the hierarchical structure of history of metals, particularly various materials. In aluminium, HC Oersted reduction process, CM Hall electrolysis, and currently there are 86 known metals. We are having currently on 86 materials. So what is in is periodic table. So as you know, these are all the gaseous groups and radiographic halogens. You know the periodic table. So different kind of materials are placed. This is the achievement of human being and various ages. History of ceramics. So ceramic pottery. These are all the ceramic. So the earliest use of ceramic was in pottery and bricks. The raw materials used for making ceramics is clay. Glass is to have been first created around 3000 BC during the Bronze Age. Athenian glass beads date back to about 2500 BC. Glass blowing was invented during the 200 BC by the glassmakers of Syria. Brooklyn has been used for over 400 years in China. It is made of special white clay and fire at temperature of 1280 degrees centigrade. In the early 90s, synthetic aluminum oxide and silicon carbide were produced. Rapid development in structural ceramic began in the 1970s. So, as you know, the history of metals, the early polymers were made for organic materials like cellulose from animals and vegetable products. And development of modern plastic technology began in 1910s, and various different years we have various modifications. Cellulose nitride or celluloid, the earliest synthetic polymer was phenyl formaldehyde resin called bakelite, PVC, polyvinyl chloride, polyestyrene, polyethylene, nylon, polytetrafluoroethylene, polyethylene triplet, low density polyethylene, high density polyethylene HDP, polypropylene, styrene, a type of formed polyester form, polyamide, thermoplastic polyester, Kevlar. So these are all the huge and very important achievement in polymers. So history of composites. So you see, So composite materials are known to mankind dates back to 4000 BC. Pharaohs, the Egyptian kings, made their slaves to use clay bricks reinforced with straw to construct buildings. In 19th century, an acid-resist tank made of phenolic resin with the asbestos fiber was the first applicant of reinforced plastics. In 1930s, epoxide were used as a matrix materials. At the start of 1940s, the reinforced plastics were used for aircraft construction. The first metal matrix composites, aluminum reinforced with aluminum, was developed in 1920s. Sorry. Major development in the composites began in 1970s. Stronger new composite form of ceramic cloth and nanotubes are under the research. So conclusion. As for the metals and materials will become the key part in our life to come, no one knows. So perhaps man will find an even better metal scattered on Mars or moon of Jupiter, or maybe scientists will discover a stronger form of plastics. But whatever it is, one this is for sure, it will have dramatic and important impact on life of all mankind. So thank you. Please subscribe my channel and support me. Thank you all.